Our next sample problem allows us to move into molecules that have multiple bonds, or as we learned in our previous chapter, bond orders that are not one. They might be two or they might even be three. So we have two sample problems to work through here, and we're going to use the concept of formal charges to also help us identify the fact that these are molecules that need to have multiple bonds. So if we look at ethylene, C2H4, again, quickly figuring out electrons, 2 carbons is going to give us a total of 8 electrons to contribute to our structure. 4 hydrogens will give us 4 electrons. We've got 12 electrons total. Let's space our pieces here. Carbons, again, are going to be central atoms. And one of the things I'll note for you is that nature often likes symmetry. So that's part of the reason why I spaced the pieces the way I did here. Connect everything with single bonds. 2, 4, 6, 8, 10 electrons. That leaves me 2 electrons left over. Which carbon atom do I put them on as a lone pair? Well, let's try putting them here. So if you left your Lewis structure at this, there's actually 2 things that would make this Lewis structure very wrong. For the first, we have a carbon atom with an incomplete octet. So what does that mean? This carbon atom only has 6 electrons around it. So it doesn't have the 8 that it wants. That's a very unstable situation, so this is very unfavorable when you're drawing Lewis structures. Similarly, if we look at what's going on here and we calculated formal charges, this carbon atom wants 4 electrons around it, has 2, 3, 4, 5 electrons around it. It has 1 more electron than it wants, so its formal charge is -1. This carbon atom wants 4 electrons around it, but only has 3, so it's missing one of the electrons that it wants, so it has a formal charge of +1. When you have 2 adjacent atoms that have oppositely charged formal charges, that might be a good indication that we have, as we used in class, the phrase, someone has a pair and needs to share. So watch what we do here. We can't add any more glue to our molecule. This is the total number of electrons we can have. But we can take these electrons that were owned exclusively by this carbon atom, and we can have them share them as a bond. So drawing a new Lewis structure here, we can draw a double bond now between these 2 carbon atoms. So again, we've not changed the total number of electrons that we have. We still have 2, 4, 6, 8, 10, 12 electrons, which is what we're supposed to have. But now each of these carbon atoms has a complete octet. If we look at this carbon atom, 8 electrons around it. It owns 4 of those 8, and that's what it wants to own, formal charge of 0. Same thing with this guy. Has 8 electrons around it, owns 4 of those 8, and that's what it wants to own, formal charge of 0. This is a very good Lewis structure. So again, let's do the same type of a treatment with nitrogen, N2. All right. Each nitrogen atom comes in with 5 electrons, so that's 10 electrons total to contribute to our structure. Only 2 atoms to connect, so if we start by putting a single bond between them, that's going to take away 2 electrons. We've got 8 left to distribute. 2, 4, 6, 8. Again, if I look at this structure, we've got problems because both of these have incomplete octets. And if we looked at formal charges that we'd have, nitrogen, again, wants 5 and owns 5 here. So formal charges doesn't tell us that there's something problematic here, but incomplete octets tells us that this guy is not happy. Again, a way to fix that is to have somebody who has a pair and have them share. So let's go ahead and do that. This guy is going to have a pair and he's going to share. But now we still have this guy having an incomplete octet. And now looks what's happened in terms of our formal charges. This nitrogen atom owns 2, 4, 5, 6. It only wants 5. So this nitrogen has a -1 formal charge. This one now has a +1 formal charge because it only owns 2, 3, 4, and it wants to own 5. So again, adjacent formal charges that are opposite in charge usually is indicative of somebody who has a pair, needs to share, and doing so now will get to the best Lewis structure that we can have for N2. Complete octets on both atoms, nobody having formal charges because each nitrogen atom owns 5 and wants to own 5.